Alright guys, here are your last set of notes for our quadrilateral unit. We're going to talk about the trapezoid and the kite. Trapezoid, we can have a couple different kinds, or a few different kinds. One, just your basic trapezoid here. We're going to talk about here, we have all the properties of a quadrilateral, so it's still four-sided, and the angle's still at the 360 degrees. We are going away from your parallelogram, okay? Look here. Here's our quadrilateral. The trapezoid is not under a parallelogram. It's only under the quadrilateral. So these properties don't necessarily exist anymore. We're looking just at these two properties, and then we're going to add a couple more. Here we have one pair of parallel sides. Okay, so with your trapezoid, we will have one pair of parallel sides. This is actually technically property number 2, isn't it? Property number 2 up here. We're going to have one pair of parallel sides now. That's why we're not a parallelogram. Parallelogram had 2. Now we only have 1. And then the third property is we have the median, which is in the middle, creating midpoints on both sides. We have a formula so we can find that. What ends up happening with this median are a few different things. Okay, first of all, these two sides are going to be the parallel. The median will be parallel with it as well. We're going to have B1 plus B2, which stands for our bases. So we use our top as base 1, bottom as base 2, or vice versa. It doesn't matter which one's B1 and B2. This is our median. Okay. The median does create, like I said, these are going to be your midpoints. So that means it's going to cut this side in half and cut this side in half. The big thing we are going to focus with right now is going to be that median and that formula. Okay. Our isosceles trapezoid. So our isosceles trapezoid on the chart, okay, is going to be a quadrilateral and a trapezoid, and we're just going to add a few other things to it here. We're going to have all the properties of a trapezoid, okay, so all these properties over here, which are also properties of quadrilateral. But now isosceles, like an isosceles triangle, has two congruent sides. You're going to have the legs be congruent, okay. So here we'll take a look at the first one. Your legs are going to be the non-parallel sides. So these two right here will be congruent. The next property here, your diagonals are congruent. So when you go from angle to angle like this, this is like your rectangle. Your rectangle had congruent diagonals. These two will be congruent. And the last thing is you're going to have your base angles congruent. So that means is not only, remember we had two bases, the non-legs are going to be the bases. And here we have two different bases, base 1 and base 2. So not only are these two angles congruent, but these two up here are also. And that's only with your isosceles. Remember, we've talked about isosceles triangle and how across from the congruent sides are congruent angles. And the same thing here. Across from our congruent sides, we got congruent angles going on here. All right? So, let's take a look at our first example. We are looking at solving, let's go ahead and label everything real quick. Here we're going to have HJ, so from here to here is going to be 32. LK down here is 60. We want to find MN, so we are finding the median. So we're going to use this median formula right here. So I'm going to use M for median. Your M is going to equal B1 plus B2 all over 2. So we're going to substitute. Again, it doesn't matter which one's B1 and B2. We're adding them, so it doesn't matter. But if we just label it like this, we're going to substitute in B1, 32, plus B2, 60, all divided by 2. We add the two top numbers to get our 92 over 2. We do our division, and we're going to find out that MN is going to be equal to 46. Okay, so I did want to make sure we walked through that one together. The next one here, we're told that HJ is 18 now. MN right here, the median is 28. We want to find LK. So we are going to have to work backwards, and we have done this before where we have a denominator, okay, and we have to get rid of that denominator first. Let's just start off plain simple here. Up here we'll write up our formula. Median is B1 plus B2 divided by 2. So let's go ahead and plug everything in. Now we have the median. The median is right here. Okay, here's our basis. Our median is 28. So we're going to have 28. We have that solution. So we have 28 is equal to base 1, 18, plus base 2, we don't know. I'm just going to put in an x, okay, all over 2. So the first thing we have to do is get rid of that denominator, like whenever we were doing the each interior angle on the first lesson in of this unit. So in order to do that, this is dividing by 2, so to get rid of it, we have to multiply both sides by that 2. So those cancel out. Over here, 28 times 2, we're going to get 56. This will be equal to, everything's gone over here except for that 18 plus x. So we have 18 plus x. And now all we need to do is subtract that 18. And x is going to be equal to 38. And that will be LK, which this should say, I've just now realizing this does not say LK. And neither are your notes. So let's scratch that out and put in LK. LK equals 38. Number 3 wants us to find the measurement of angle D. Angle D is over here. Now there is something that was not covered in those in the notes, or sorry, the properties up there. But what we need to know is that our consecutive angles that are not congruent will still be supplementary. So we still have that property running for us. And what that means is here we know that our base angles are congruent. So D and C are going to be congruent, right? Base angles congruent. But we're also going to have a pair of supplementary angles right here for them to all add up to 360 degrees. So we're going to add this new one, your consecutive. You can even say your opposite. Honestly, your opposite ones are going to be supplementary. That's what I might say in the classes. Opposite angle, or sorry, consecutive angles supplementary. You know what, guys? Let's change that. I'd rather say opposite. So we have opposite angles are supplementary. This is with your isosceles trapezoid. Okay. So with that being said, if they're supplementary, they add to 180. So if angle A up here is 125 that we can barely see, all we need to do is subtract that 125 from the 180, and we're going to get 55. So C, and well, if we're using opposite angles are supplementary, then we've got angle D is going to be 55 degrees. On number 4, apologize about that, we want to find the measurement of angle L. So again, we look at here, if we go back to what I said earlier about the opposite angles being supplementary, these opposite angles are going to add up to 180. So if we have opposite angles are supplementary, we know that we take that 180, we subtract the 40, and we're going to get 140 degrees. So that's going to give us the measurement of angle M. But then we remember also that we have two pairs of congruent angles. So base angles are congruent. So here base angles are congruent, meaning the measurement of angle L is equal to the measurement of angle M. So angle L is going to equal that 140 degrees. Next, we got a couple things we're going to work on here. We're going to set both of them up. I'm going to pause it. You're going to pause it. You're going to solve both for X and for Y, and then the answers are going to pop up like we've been doing with these videos. We have an isosceles trapezoid. We have that PR, so this entire diagonal is going to be 3x minus 7. And we have that PT. They're skipping all this around on us, aren't they? Sorry. PT is 3y, so over here I'm actually going to do, if you're using different colors, I'm going to do a different color. PT right here is 3y. RA over here is going to be 39. And TA, which is this diagonal, is going to be 20. So a couple different properties here, a couple different properties we're using here. To solve for x, we need to remember that our diagonals are congruent. So diags are congruent. So we just set these equal to each other. 3x minus 7 is equal to 20. With our sides here, the legs, we need to remember that they are congruent. So here we have legs are congruent. So we set those equal to each other. 3y equals 39. Please pause this. The answer is about to pop up. Giving you a second to get it paused. Second. All right. And the answer is about to pop up. Bam. Just like magic. There's your work. You should have gotten 9 for x and 13 for y. All right. Last one, the kite. All right. Last one we're going to look at is the kite. Here. Let's go fill out our flow chart first. Let's get that out of the way. Back to the trapezoid. We remember that we have exactly one pair of opposite sides are parallel. And this one is saying exactly 2 pairs of consecutive angles are supplementary. And here I want you guys to notice this is also going to mean your opposite angles are supplementary. Okay, that's all that was what we were talking about earlier. At first I put it consecutive, but I was like, you know what? I didn't make this flow chart, but I kind of like it saying the opposite angles are supplementary. It makes more sense. Next, your isosceles trapezoid. We're going to have all the properties of a trapezoid, of a regular trapezoid, what we just did. In addition to that, your non-parallel sides, which are the legs, okay, they're going to be congruent. The diagonals are congruent. And your base angles are congruent. A lot of congruent stuff with this isosceles trapezoid. All right, let's talk about the kite. We've got some problems, and let's fill out that flow chart real quick. So, actually back to the flow chart. I keep changing my mind. So with the kite, noticing that we're not stemming from the trapezoid nor the parallelogram. So the kite, we're ignoring everything over here. The kite, only properties we know of right now is that it's a quadrilateral with 4 sides and 360 degrees sum of the interior angles. So this one's going to go off somewhere in the direction. What we're going to have is we're going to have 2 consecutive sides, one after another, are congruent. And what this one looks like, here's property number 1. We're going to have these 2. The 2 shorter ones are going to be congruent, and the 2 longer ones will be congruent to each other. Next, we're going to have the diagonals are perpendicular. So this is like the rhombus and rhombus and square. We do have diagonals that are perpendicular. So we have perpendicular right here, number 2. So what's going to end up happening is you're going to wind up, just like with the square, the rhombus, we're going to end up having a right triangle. Okay, I know in the last notes I wrote angle at first. We're going to have a right triangle, 4 of them. But these are not congruent. But we have 4 different right triangles, so probably be using Pythagorean Theorem again. Number 3, we have 1 pair of opposite angles are congruent. Okay, 1 pair of opposite angles are congruent. And these are going to be the angles between the non-congruent sides. Okay, not the angles between the congruent sides, not those, but these 2 right here. So you go to the angle, go from the shorter side to the longer side, the angle that's in that vertex right there. And the last one is your main diagonal bisects the cross diagonal. What that means is the longer diagonal is going to bisect the shorter diagonal. So right here, this is going to be bisected. They're not both bisected. We only have one diagonal bisected. Okay? And the way you can remember that is it says it bisects the cross diagonal. Well, if you draw the representation of a cross, you always do that longer one downward first. To complete drawing that cross is when you do that horizontal one. That's the one that gets bisected. All right? So on problem number 1, we're going to look at, this is a kite. We want to find BC. So we're going to find this guy right here. Well, first of all, we know that our diagonals are perpendicular. So we have 90-degree angles. Therefore, we have right triangles. So right here, we have a right triangle with a leg of 5, a leg of 12, and we're going to find the hypotenuse. So again, if that's just kind of drawn off to the side away, like I did on the other with the rhombus, I think it was, square, we have that 5 here, and we have that 12 here. We're looking for C. So we're going to use Pythagorean Theorem, a squared plus b squared equals c squared. I'm going to pause it and let you finish this, plug it in A and B, and then resume it to find your answer when the answer pops up. I'm about to pause it. Please pause. And there you go, like magic. There's your work. Okay, double check your work. Make sure you did Pythagorean Theorem correctly. Number 2, we're saying that if HJ is 7 right here, we want to find HG right here. So what property do we need to remember? That we have 2 consecutive sides are congruent. I'm going to kind of abbreviate that. Consecutive sides are congruent. Man, Ms. Collins, you could really work on that handwriting. So that means here, these 2 sides, because they're both the shorter sides, these will be congruent. So segment GH will be congruent to segment HJ, meaning their measurements will be equal. So GH will equal 7. Oh, H. Okay, I switched the letters around. It's okay. We've learned. Doesn't matter which order the letters go in. So here we have 7. Number 3, we want to find the measurement of angle JRK right here. There is absolutely no adding, subtracting, solving for anything that we have to do here, because all we have to do is remember that your diags are perpendicular. So we're going to have a 90-degree angle, so it's automatically just 90 degrees. Bam! Really easy problem to do there, right? All right, now we are going to find the measurement of angle Z right here, okay, using this kite. Now we are given the measurement angle W and measure angle Y. So the first thing we need to understand here is that we are going to have the sum is 360 degrees, because that is a quadrilateral property. So what I'm going to do is I'm actually going to write that part over here, okay? We're going to put sum of interior angles is equal to 360, because we're still quadrilateral, right? But we have to discuss something else first. That's all fine and dandy with, knowing that they're that we've got the sum, but what I need you guys to understand here is we have 2. We're missing 2. So how are we can't add 2 different variables together. But what you notice is one of our properties of the kite is you have exactly 1 pair of opposite angles congruent. Well, if you see angle W and angle Y are opposite, they're not congruent, which means angle X and angle Z have to be congruent. So, since they are the same number, and we're going to solve for something, we're missing something here, we can just put in a variable of X for both of these, because they're going to represent whatever X is, that's going to be both of those. So the other property we're looking at is if we have 1 pair of opposite angles are congruent. Therefore, angle X is congruent to angle Z. So if we just use the letter X to represent those, let's go ahead and set up our equation. We're going to add all 4 of these together and then solve for X. I'm going to go ahead and just add these 2 X's together and just throw 2X in my equation because it's just, I can see it right there. So I have 2 X's plus that 60 down at the bottom for angle Y plus the 80 for angle W, all equal to 360 degrees. Again, here is your pause, solve it, and then check your answer. It is about to go on pause. The answer is about to show up. And there's the work. We should have come out with 110 degrees for each one of those. So that way we don't, we don't have to sit there and add, because I know some of you will want to add 60 and 80 together, subtract it from 360 and divide by 2. You can do that as well. It's exactly what we did. We just did it algebraically. So there are all of your quadrilaterals. Let's go fill out our flowchart before I push stop on the record and then realize it later. Whoops-a-daisy. So with our kite over here, we're going to look at exactly 2 pairs of adjacent sides are congruent. The diagonals are perpendicular. We need to keep, some of us need to keep reminding ourselves it means 90 degrees. Exactly 1 pair of opposite angles are congruent. And the main diagonal, the longer one, is going to bisect the cross diagonal. And there you go. There are your notes for your quadrilaterals.